And my clock has just ticked over the hour, so I guess it's a tight agenda and we should start. So welcome to the Application Aware Networking APN BOF. You have 3 chairs today, Bob, Daniel and myself, Adrian, and Martin, our AD, is also here. The chairs have decided to sort of split the roles with Bob looking after slides, Dan looking after the queue of people and the chats, and me being the person who gets to speak to the chair's slides. Reminder that this is a working group forming BOF, which means nothing more than at the end, or the purpose of the meeting is to gather information for the AD to decide whether there's work here for the IETF and whether or not to form a working group. And the chair's job is to let the proponents explain their ideas and allow the community to ask questions and dig and express their opinions. So, slide please. Just because it's a BOF doesn't mean the note well doesn't apply. In fact, it probably applies pretty strongly because here are some new ideas coming along. So if you're not aware of this, please go away and read the references. Understand that if you contribute in the chat or at the microphone, that is an IETF contribution. Next slide. This meeting is being recorded. Be aware. The links are all in the HTML agenda. The blue sheets are automatically collected. Thank you to Linda and Carsten for taking notes, and it's in Etherpad, or CodeMD. So please jump in and contribute and make sure that what you say is recorded correctly. Slide. There's been quite a lot of work around APN for a couple of years. You can see information in the data tracker, both about this BOF and the documents that have been posted. And there's a mailing list with an archive you can join. The previous meetings have been recorded in GitHub with notes and minutes. And I'm going to ask, can everybody who is not actively talking, please mute, or I will mute you all. Thank you. Thank you. Okay, so yes, there's a GitHub archive you can go to. Next slide. Here is our agenda, and this is your opportunity to bash the agenda. Our intention is that when the proponents are presenting, which is items 4 through 8, there is space to ask questions, but the questions are for clarification. That is to say, I heard you say this in the presentation, what did it mean? Or were you trying to say this? And then we'll hold the real debate up until the open session at the end, when there'll be opportunity for the proponents to come back and answer questions as well, but we hope there'll be a good exchange of opinions. Anybody want to make any comments on the agenda, please? Hearing nothing and seeing no hands, we'll move on to the next slide. So this is Martin's opportunity to tell us why we're here.
Thank you. Do you hear me correctly?
Yep.
Okay, great. So thank you all for being here. As shepherding AD, what I'll be looking for or looking at during this session is twofold. You already started hinting on that, Adrian, but first, is there standardization work to do in that space? And here I mean what are the concrete use cases and problems that we would need to address in IETF? And do these problems or use cases need interoperable solutions? Because that's why we're doing standards. And can or can't they be addressed with existing mechanisms? So I believe a good part of the session is dedicated to that. So I'm hopeful we will be able to conclude. So I was saying twofold, sorry. So is there standardization work to do? And if so, that's the important part for me. What is the best way to achieve that? Is a working group the most effective way or not? So, and in that context, I'll be looking at two things. And specifically whether there is critical mass for the work. When I say critical mass, I mean both in terms of number of people willing and able to do the work over, let's say, 2 or 3 years. But also, and that is very important, is there sufficient diversity of interest in that topic? Because diversity of interest is what makes our standards robust. So that's my main focus point during those 2 hours, and I'll be specifically looking at that. Proponents have come a long way since they first introduced that topic in IETF, and they have done quite a lot of work. I have to thank them for that. Quite a lot of work in getting and addressing inputs they have received from the community, specifically, for example, when they presented that in several sessions during last IETF, but also from IESG and IAB. I know the topic may have started not necessarily on the right foot with the use of application. I think Adrian, you'll have a say on that later. But please give the proponents the chance to expose their refined ideas, listen to them, and please comment constructively. I think this is important for us to have a fruitful discussion and define the proper way forward. Before I close and hand you back the microphone, I want to thank you, Bob, Adrian, and Dan, the 3 of you, for all the work you did, because you pulled an enormous amount of work to prepare that Bob session. So thank you very much. Back to you.
Lovely, thank you, Martin. Okay, I've got just a couple of slides to set us up, and one of them builds, well, actually both of them build on what Martin just said. The first is the name, APN, Application Aware Networking, has a long history behind that name, and APN6 was mentioned in an ID back in 2019 and then presented in 6-man. And since then, the function and the meaning have evolved considerably. There's quite a lot of difference between what the proponents are going to talk about today and what was written in the original drafts. So please don't get hung up on the name. A name can be changed to anything. And the function that you're going to hear about has outgrown that original name. So please listen to the presentations. Give the proponents a chance to say what it is they want to do now, not what was in the early drafts. Draw your understanding from the technical details and not from the name. Next slide. So as we go through the BOF, the chairs thought that it would be really helpful to have some questions in mind. The presenters and you as a community don't have to answer these questions, but thinking about them may help and help guide the discussion at the end of the meeting. So we'll put this slide up again at the end of the meeting when the open discussion is there, not because you have to talk to these points, but because they may help clarify in everybody's mind what's going on and what input they want to give to the discussion. So with that, I think, yeah, that slide is for the end. So we will move to our first presenter, who is Robin. So if you'd like to unmute yourself, Robin, you'll be good to go.
Hello, Adrian. Can you hear me?
You're coming across fine. Yep, and we see you as well.
Okay, great. Okay, this is Zhenbin. I will have an introduction about APN. Okay, next slide. Okay, so the first is what's the APN? So APN is the abbreviation of Application Aware Networking. APN is a framework where APN attribute is introduced at network edge devices. And the APN attribute is structure fields. And the APN attribute is carried along with the tunnel encapsulation. And the APN attribute will be used for policy enforcement on the nodes within an APN domain. And in short, so that's APN classify a packet at ingress to the APN domain. The classification can be based on the 5 tuple information, VLAN information, etc. And APN encapsulates the packet into a tunnel header within an APN domain and traverse the APN domain. Third one, APN will route, process, and forwards the packet within the network using policy dependent on the APN attribute. At last, APN will decapsulate the packet on egress. That is, the APN will remove the APN attribute along with the outer tunnel encapsulation. And in the process of promoting the APN work, there's the concern on the privacy. Yes, the privacy is very important. So here, the APN will not depend on being able to determine user identities or which applications they are running by inspection of packet header. And the working group must not publish any specification that risk violating user privacy. Okay, next slide. So here, this is a reference diagram of the APN framework. So here we can see the packet will be sent from the source to the destination. When the packet is sent from the source to the APN network domain. So this here, this is the normal packet. When the packet arrived at the edge of the APN edge of the APN domain, the APN edge will determine the APN attribute according to the mapping from the existing packet header information to derive the APN attribute. Then the APN edge will encapsulate the APN attribute to the packet along with the tunnel encapsulation. So then the tunnel, the APN packet will traverse the APN domain. The APN attribute in the outer tunnel header can be used for policy enforcement. The policy enforcement can be divided into APN head, APN midpoint, APN endpoint. So this is depend on the division is depend on the different role of the policy enforcement. So when the APN packet leave the APN domain as the APN edge, the APN attribute will be removed along with the outer tunnel header. So then the normal packet will be sent from the APN domain to the possible destination. So from this reference diagram, we can see the APN attribute will be only used in the APN domain. So here, just a clarification, APN domain is a logical concept. That means in the physical environment, it can be multiple network domain controlled by the same operator. A second one, the APN edge and the APN head, that is a logical node. That means in the physical, the APN edge and the APN head node can be the two nodes in the APN domain. And also, there's maybe the case, the APN node functionality and the APN head functionality can be implemented on the same network node in the physical. Okay, next page. Okay, so this is how does the edge node set the APN attribute fields. The edge node must be configured or programmed to map from the packet header fields to a structure APN attribute. The edge node may look at all of the URL fields of the packet header, the available information, including the 5-tuple information, including the destination address, source address, etc. And maybe the layer 2 information, VLAN information, and also maybe the access port of the packet. And also this is a one-off cost as the edge and does not need to be repeated as a transit nodes. That means the mapping can be done as the edge node, so the APN attribute can be used in the transit nodes of the APN domain. And here they are in the process of promoting the APN. Some experts propose that the packet may be encrypted so that some fields of the packet header may be not accessible. So there's the two possible ways. So that's the first way, the APN function may be reduced. That is only use the 2-tuple information for the mapping to the APN attribute. And the second way, there's other information such as the access ports or the VLAN information can be used for APN. This depends on the configuration for the possible mapping. Okay, next slide. Okay, and then the network knows how to know what to do. So the network knows will do the policy informants according to the APN attribute. The operator of the APN domain configures the mapping from the APN attribute to policies at each policy enforcement nodes. The methods can include following way. First one is configuration at each node through the CLI. Second one, programming from a central management station through the YARN model, or that's use the SDN southbound protocols. A third way is to distribute using the control plane protocols. Next slide. The goal of the APN. APN attribute allows the network device to only look at one easily accessible field in the tunnel header. So that means comparing the traditional 5-tuple information for the classification. So now that's only use one tuple information from the APN attribute for the possible policy enforcement. Second one, because the 5-tuple information may be not available because the original packet may be encapsulated in the tunnel. So that's the 5-tuple information is not available. So the APN attribute in the tunnel header can go on to be used for the classification and the policy enforcement. Second, the APN attribute allows to simplify the policy control at every policy enforcement point within the network. So that first, the APN attribute allows to reduce each matching entry of policy filter, since it's only one field. So that's because in the traditional way, if you use the 5-tuple information, it has to introduce the complex forwarding algorithm and expensive hardware resource. But the policy enforcement based on the 1-tuple information can reduce the complexity and save the hardware resource. A second one, because the APN attribute is relatively stable, so that it introduces the possibility of unlimited state or policy filter entries. So that means because there's the cases that the different user, the enterprise user may access the network in the different places. So the same APN attribute, but with a different source address. So that if the source address of the user group is changed, so the policy will be changed accordingly in the possible network nodes. But the APN attribute is relatively stable, so that it's not necessary to change the policy enforcement based on the APN attribute. So that's similarly, so that in most cases, the APN attribute is centralized, configured, and distributed to all the policy enforcement points. Third one, the structure APN attribute allows to express fine granular service requirement. So here, there's the example of this requirement defined for the different user group and the application group. For example, for specific user or applications in the for enterprise, we can have the market user group, and we can also have the R&D user group for the finer granularity service. Last one, the structure APN attribute allows to match the evolving the fine granular different network capability. That means now the scalability of the network service can be has been improved greatly. For example, we can implement the SR policy. That means a huge number of SR policy can be implemented in the network. So that's use this fine granular APN attribute, we can implement the fine granular policy enforcement. So that's all the goals of APN. Okay, that's all the introduction of APN.
I think we should go with Karati, but there's a couple questions also in the chat. So maybe Karati, if you want to start with your question first.
Sure. In slide 5, you talk about policies, and you talk about how the policies can be enforced, but not what the policies should be doing. So can you give some examples of policy enforcement? What kind of policies they would use? Is it a per hop behavior? Yeah, go ahead.
Okay. So I means the next the APN use case will have the more details about this policy enforcement. Here, this is just a simple example. That means we can match a office user and to action is steering to a SR policy or network slicing. So that's the policy enforcement. Okay.
Okay, thanks. I'll wait for the next presentation.
Okay, thanks. Great.
Greg, you may want to go.
Thank you for the presentation. From what you describe, how you characterize APN attribute, it seems very similar in philosophy and function to IPv6 flow label. So, because it appears that what you identifying with APN is a flow, and then you enforce some policies to treat this flow through the tunnel. So, which is the purpose of a flow label. Can you point to what you see as a difference that motivates to introduce a new structure in tunnel encapsulation and not to reuse available flow label? Thank you.
Okay, thanks. Thanks, Greg. So in fact, in the following presentation of the gap analysis, there we will describe this the gap analysis of the IPv6 flow label. Here just is a small clarification. IPv6 flow label now is always used for the ECMP purpose. So that's I think that's a specific functionality and is only used for the IPv6. So the APN attribute, we wish to define the generalized APN attribute for the flow identification. That's the difference. Okay. Next.
Yes, Tom, go ahead.
Thank you for your presentation, Robin. Having 5 pupils to look up the APN attribute sounds like it may create a lot of permutations of attribute values at the edge. If these are to be downloaded from a controller or configured centrally and downloaded to all of the edge policy enforcement nodes, it sounds like we're going to create a large table of lookups there for a large number of APN attribute values. Is that something that you're concerned about in terms of?
Yeah, Tom, I'm not sure I get your point at all, but in fact, this is the controller definitely to download the possible configuration to implement the mapping to the from the existing packet header information for the APN attribute. Yes, that's
when you take source address, destination address,
yeah,
Q and Q tag, all those things, you put them all together, you could with millions of users, you could end up with a lot of permutations of different attributes that would need to be identified and applied to traffic. So that sounds to me like a very large lookup table stored in a local device.
Yes, that thanks. I got your this point. This is a good question. Yes, but I think that's the possibility. But I think that's in the actual deployment. I think this is the for specific user of the network service. So I think that's the possible classification of the APN attribute should be limited. But I think that's here I explained that's there's the possibility to use one tuple of APN attribute can gain the higher scalability than the traditional way, which use 5 tuple information. Yeah.
Hey, thanks, Robin. Guys, we need to get moving. There will be a good amount of time at the end of the session for more question and discussion. So I suggest we move to the other presenter. I think that's Louis next.
Okay, we can see in the chat box. Okay.
Yeah, can you hear me?
Yes.
Hello? Can you hear me? Okay, perfect. I cannot see yet the slides. So not okay now. Thank you. So next, please. So I'm not sure if there is some delay. No, okay, here. Thank you. So, well, the idea here is to present some illustrative use case in order to, illustrate, let's say, the applicability of APN of the APN approach. So the APN attribute will be in the tunnel header. So we will consider the application of this tunneling in what is called an APN domain. I will take some time to let's say, prepare the scenario that we will comment later on. So we will consider an APN domain, which is under the umbrella of an operator or an administrative domain, that could be realized from different network areas, such a way that we could have different subdomains, let's say, within this APN domain. The APN attribute, at the end, what is intended to allow is a finer grain enforcement in such a way that, based on the attributes of this field, of this tag in the tunnel, we could apply these policies. And here we will illustrate with two of them, with performance measurements and also with traffic steering. So next page, please. So the scenario, as you can see in the picture below, so all of this is behind an operator control, and we have three different segments, two metro areas and one backbone area as well. We have considered, for illustration purposes, this lease line service, essentially with the idea of connecting, for instance, cloud sites from a cloud provider, and using in these examples MN routing version 6, but we could use on other encapsulation. So it's not dependent on the encapsulation at all. So what we consider is that we will essentially create a tunnel between the PEs, connecting the two different sites, and also we consider that we will not have, or we will have a loose TE traffic engineering setup between these three different areas. The reason for that essentially is to not create too much state on the metro areas and what is here labeled as city A and city B. So next page, please. So regarding the two examples that we will provide, according to policies, we will talk first about the performance measurement in the IP backbone. So without having APN, the circumstances for applicability of this policy could imply in each of the transitions between the metro area and the IP backbone, and then from the IP backbone and the other metro area, to check the 5 tuples that are in the inner label of the tunnel. So somehow we will need to process the tunneling and then the other header, the additional header, in order to identify what could be the performance, the triggering of the performance measurement to apply for the required flow. In this in this case, in situ IAM approach. So this is expensive in terms of processing, and the idea of applying APN in this respect would be to essentially to alleviate such processing. So if we go to next page, probably we could make more evident this fact. So the point here would be in the entry PE, the one that is on the left. Essentially, we would have the the need of processing these 5 tuples coming from the original packet sent by the CE, and according to that, apply or apply the proper APN tag to the respective packets. With that tag in the tunnel, then in the different boundaries between the metro areas and the IP backbone, would be easier to check, simply to check the APN attribute in order to trigger the measurement of the specific flow. So this would be the case for performance measurement. We can move to the next page, please. Here, the idea would be to apply traffic steering. We will see traffic steering and together with the performance measuring as well. So in this case, without APN, essentially we would need to do the same process as before. So checking the 5 tuples that are in the inner label of the tunnel messages, and based on that to apply the specific steering. Because we have here, we consider as assumption to have a loose traffic engineering, the granularity that we could apply to the path in the IP backbone part, it could be probably, could not be the more optimal or the best to be applied. So again, essentially here the situation would be the need of processing these 5 tuples as we saw before. So next page, please. So when relying on APN, what we could have is a simplistic way of applying the policies. So in such a way that when we transition from the CTA metro area to the IP backbone, we can look just simply to the tag, the APN tag in the tunnel, and then apply a more optimal policy that in this case, for instance, is represented by the fact that the traffic will go through the segment routing path number 2 instead of going through the segment routing path number 1. Apart from that, and based on the same information of the tag, we could also even trigger a second policy that would be in the applicability of measurement for this second flow, as we saw examples before. So essentially here, what we intend to highlight is the flexibility of the mechanism for triggering more than one action, and also the simplicity in the processing by focusing on just this simple attribute. So next page, please. So apart from the use cases mentioned before for illustration purposes, there are a number of other scenarios that have been already documented, and plus some others that are more or less in the discussion. And this is just to show some references among all of them. And I think that with that, I'm finished. Next page, please, just to be sure. Okay, well, just the summary. Well, we have used this cloud list line service as an example. There are others documented as we saw before, and we have considered these 2 policies: the triggering of performance measurement and the traffic steering. And well, that's all from my side. Thank you so much.
Greg, if you want to go with your question, please.
Go back to performance measurement use case slide. If you can clarify to me, so you have 3, what appears to be 3 domains. And is it single tunnel that goes from CE to cloud?
Yes.
So it's a single encapsulation, single tunnel encapsulation that goes for all these 3 domains, regardless of administrative ownership.
The administrative domain is unique, so this will be being handled by the same operator. Consider the fact that the same operator has different areas, and managing each area separately. This is why we call it the domain. But
that's probably very unique case when you can cross 2 cities and IP backbone and not to leave an operator. I can imagine that such case can be constructed, but in my experience, that is rather than exception than the normal case. The normal case would be that you will probably cross at least 3 operators here.
Sorry, but I would say it's not the normal case, at least in my experience.
Well, again, so we probably have different experiences, but I think that it needs to be very clearly stated that your assumption for this use case is that all 3 domains are managed by the same operator. It's a not multi-operator environment, but a single operator multi-domain environment, because that changes the scenario and changes the perspective and changes the mechanics.
Okay.
And as a result, I believe it changes applicability of APN, because if we look from IOM, then by IOM applicability, that IOM has to be removed at the edge of the domain. So if you have multiple operators, I would imagine that it will be applicable in this case, but if you have multiple operators, I would expect that your tunnel encapsulation will be removed at the edge of your operator's domain. So
yeah, Greg, you are totally right. So it was my fault not explaining properly well in the first slide. There was this idea of having just a single administrative domain managing these different domains. I totally agree with you that if we cross we cross the boundaries of operators, this should has to be removed. That's clear. So it was my
okay. Thank you.
Thank you.
Guys, before we move to another question, again, we're trying to stay in time. So I'd like to invite the next speaker, Jayan. And again, there will be at least a 25-minute discussion and question at the end. So Jayan.
I'm here.
Good.
Just waiting for the slides. Hi, my name is Gian Mishra. I'm with Verizon, and I will be going over the deck related to APN and why existing mechanisms are not enough. Next slide, please. Next slide, please. Thank you. So why are existing mechanisms not enough? So today, so on this slide and the next slide, I'll be going over existing mechanisms. So the first mechanism, DSCP. So for IPv4 and IPv6 marking. So DSCP has been around for a long time for marking, and it's been used in the industry for decades for classification and providing SLA to customers. So really the big piece here with DSCP is the field is for what the type of granularity that we would like to achieve with APN is a fairly high grain granularity and what we call, I guess, a fine grain SLA versus a coarse grain SLA. And with DSCP, even with the 64 bits, it does not provide the granularity that we require with APN. The next one, IPv6 flow label. So IPv6 flow label, so with RFC 6437, the primary goal of V6 flow label in use cases by operators as well is for stateless ECMP load balancing. There is a stateful component as well, but in general, most operators, the use case for IPv6 flow label is localized, and it's a 5-tuple 20 byte hash that's used for as an input key to a hash function that provides that localized load balancing function. MPLS entropy as well, RFC 6790 as well. It has its use case, and that's for providing the same hashing function for load balancing and eliminating control plane and data plane state. Pseudowire as well, fat pseudowire has been around for many years as well, and that as well is used for being able to look into the payload and look at the source destination to build that hash for as well load balancing function. The next one is SFC, so service function chaining. So this subscriber identifier is there for NSH in the context header. So that is as well, it's used for service function chaining overlays and carrying information between service function nodes for service function forwarding. So it has its specific use case that it's made for. The next one, number 4, Iom Flow Id. So the Iom Flow Id is used to create and export data of the same flow for multiple nodes and multiple packets. It's used only within the IOM structure and added to data packets for IOM purposes. Next slide. Please, thank you. So number 5, binding SID. So the binding SID is bound. It's used in SRT for segment routing to bind the candidate path to bind the candidate path to the forwarding plane for SRT for strict or loose paths. And the binding SID can only be used with SR. So for the SR data plane, and that's SR MPLS or SRv6. Number 6, flow spec label. So the flow spec has also been around for a long time, and it has its purpose used for DDoS mitigation, and it's been deployed quite a bit by providers. It took on that role, I guess, after RTBF became obsolete, and used traditionally for BGP and MPLS VPN for identifying and providing DDoS mechanisms. And I guess the caveat there, it's only applied to MPLS networks, or BGP is used to distribute the flow spec rules bound with labels. The last one is the group policy ID. So the capabilities of VXLAN GPE protocol can be extended to find a next protocol shim header that are also used and implemented for new data plane functions. And the group policy ID shim header can also is used today in Geneve, that's being standardized, as well as VXLAN GPE to carry metadata. So these 7 different mechanisms that do exist today, and they have their data plane specific function, and they have their goal, and they're tied, and tied to their specific data plane, the specific functional goal. They're all possibilities that could be used for APN, but I think the granularity is more coarse, and it's not the fine grain granularity that we're looking for APN, for the application ID attribute. Next slide, please. So as far as the gap analysis, so existing solutions were all developed for various specific scenarios. They have precise and limited functionality. Each applies to a particular data plane. They're not generic across multiple encapsulations and forwarding technologies. APN's aim is to define an attribute that is generic, can be used for various policy enforcement functions, enables service provisioning, and can be carried in all IETF data plane encapsulations. So what we're looking for is really a ubiquitous approach that can be applied, that it's really data plane agnostic, that it's not tied to a particular solution or a particular function, but a data plane encapsulation that can carry a application-specific attribute that can be used across all data planes in the same data structure, but applied to all data planes. Next slide. Thank you.
Tarek, if you want to go with your question, please.
Yes, hi, can you hear me?
Yeah.
Yeah, Jan?
Yes.
Yeah, I agree pretty much with your literature review and the gap analysis. I noticed you missed the work being done on carrying an aggregate ID in the packet for network slicing. Not sure if you had a chance to look at that. There's a lot of resemblance in in what an aggregate ID can do in application-aware networking. I encourage you to look at that if you haven't.
Yeah, thank you, Tariq. I believe I have looked at that, I guess the aggregate ID for network slicing, and then that is a good point that you bring up. So I mean, that's definitely something to look at, and then maybe something that could actually be tailored and could possibly work with APN. But I think in the gap analysis, we'll definitely look at add that into the deck as something to investigate. Thank you, Tarek.
Thanks, Alisa. You want to go?
Yeah, thanks. In the very first set of comparisons there, you said that the identifier spaces weren't big enough. So I was wondering what size of identifier space is needed. Like how many bits does this label need to be?
So I'll try to best answer the question. But the answer will be in a slide deck actually further. Yeah, I think it might be the next one or the one after, but we're going to go in detail into the specifics of the application ID. I believe it's 32-bit, or I believe it's like 16 or 32-bit, but the details of that it's right here on, I guess, on the screen now. So I guess the answers will be coming shortly. Thank you.
Thanks. Shangfang, you want to go with your presentation?
Yes, I'm here. Can you hear me?
Yes, we can hear you very well.
Okay. Hello, everyone. This presentation is about APN attributes. As mentioned earlier, APN refers to the application-aware network, which attempts to perform application-level traffic steering and the network resource allocation. So the question is how to make the network more precisely know the requirement of different applications. The basic idea is that application-related information can be carried in each packet to tell the network how it should be processed. This application-related information can be considered as attribute. The structured APN attribute can be used as opaque value to map to a policy, as mentioned by the earlier speakers. So the APN attribute will be attached to a packet to indicate how it should be handled in the network. In specific, the individual fields of the structured APN can be inspected and used to indicate which policy to apply. Currently, this presentation proposes two APN attributes. The first one is APN ID, and the second one is APN parameters. So we will talk them one by one. Next slide, please. APN ID can be used to identify the policy on the various policy enforcement points within APN domain. The values of APN IDs are assigned and integrated in the local administration, determined by a mapping of the packet fields as instructed by the org controller. So here the domain may be APN domain may consist of multiple network domains operated by a single operator. The APN can be used to identify the policy on the various policy enforcement points with APN domains. It can include the following informations. The first one is APN group ID, which identifies the application group of the traffic. It does not refer to any specific application. The second one is user group ID, which identifies the user group of the traffic. So it is clear that the different combination of the ID can be used to provide different granularity of the service provisioning and SRE guarantee of the traffic. Next slide, please. This is about APN parameters. APN parameters can provide the specific level of performance requirements to the network layer. The typical parameters include bandwidth, latency, packet loss ratio, and jitter. So they are very straightforward. But I also want to mention that it is a parameter is open, and other parameter can also be introduced based on the actual requirement and use cases. And the different combination of the parameter for further can be used to express more detailed service requirements. And together with the APN ID, the parameters can be used to map to appropriate tunnels or OSI policy, and that can satisfy these service requirements. Next slide, please. So this is, thank you.
Alisa, you're still in the queue. Do you still have a question? You want to go, or?
Don't know how to use Meetup.
Because if you want to go, now it's the time.
Okay, so I have two questions. The first question is that you mentioned the APN attributes is opaque, and then you also talk about it has structures, and the router network devices in the middle will inspect individual fields in that structure. So that seems to be contradiction to me. If it's an opaque number, you shouldn't be looking into individual fields of the opaque number. That's the first question. Clarify that. The second question is about APN attribute where you specify the bandwidth, jitter, latency, all those things. So do you expect a transit router to look at those raw numbers in terms of bandwidth, latency, jitter, and determine how to forward traffic?
Regarding to the first question, I don't think they are contradictory with each other, because the APN may be opaque because it is derived from other information. For example, 5 tuples and this 9 ID. So it is derived from this specific input information, and it may be structured because the APN may take, my understanding is that, and my expectation is that APN may take the hierarchical structure, which may include the, for example, for enterprise users, it may include the ID of this enterprise user. It also may include some information about the department of these enterprise users. So it should be structured. That's my understanding. Regarding the second question, yes, there's several parameters may be contained in the parameters fields, and the process of the parameters by the transit node may be depend on the actual requirements or the policy enforced on the policy enforcement points. This depends on its actual use cases. That's my understanding. Thank you.
Shuping, you've been in the queue. I think you want to clarify a few things. Do you want to grab the mic and express your views? Yeah, go ahead. Shuping, you there? I think your mic doesn't work. Can you double check quickly before we move to someone else? Okay. Lou, if you want to go with your question.
Yeah. Can you describe how this work differs from DetNet, where we already have 6 tuple classification as well as can support all the service parameters you've listed?
Sorry, I have not been involved in DetNet. I hope my understanding is that if APN architecture or the attributes can be adopted, I think it will be helpful to, or it will be useful for the DetNet and to solve the to meet the requirements of DetNet. I think that they will this will be give support to .NET.
It seems to me that the architecture that you're talking about here is maybe a subset of the .NET architecture. Maybe it's for someone else, one of the other presenters, to respond of how it differs, and we can talk about it maybe later.
Okay.
Hello. Hi. Can you hear me?
Yeah, we can hear you, Shuping. Go ahead.
Okay. Yes, thank you. Just a clarification. Yes, first, I think to the .NET. .NET is one of the network services we can support. And so the .NET is used to provide the guaranteed latency within the network, and APN is used to express the services and to be better matched to those one of the deterministic paths, that is to .NET. And how to integrate these two work, and we can continue working on that. And a bit to clarify to Jeffrey, and yes, the opaque and structured is not conflicted, and we have the structured APN attribute doesn't mean we have the clear text within this field. So that is difference. And also the parameters, how to use the APN parameters is another topic we can investigate, but definitely I don't think it will be used in the transit node. So yeah. Okay.
I look forward, I'll get out of queue, but I look forward to hearing the differences between what you're describing is the APN architecture and APN solution that isn't already met by .NET. Thank you.
Good. David, if you want to go with your question, please.
Yeah, I wanted to ask about the opaque lookup. There was something on the earlier slide that implied the whole APN attribute, whole APN structure, both the ID and the parameters, could be used to do an opaque lookup. I'm wondering how that can work when you have fairly rich parameters. What exactly is the lookup operating on when it's running opaquely?
Shuping or Shangfang, if you want to provide an answer.
Yes, may I?
Yeah.
Yes. So yeah. So here, when we put opaque, it just the operators doesn't need to know the identities of the users and even their group of the applications. So the operators only want to do the policy enforcement more flexibly, more efficiently, and it doesn't need to know the identities, which will eliminate the privacy issues. But with this ID, we have so many IDs as in the stated in the gap analysis, is you can use those identifier to do the policy enforcement. That is the whole point.
Okay, let me make sure I understand what you said. It sounds like what you said was that the identifier is opaque in that it hides the parameters from which it was defined, but it is visible to the network, and the network expects to understand it and use it accordingly.
Yes, so this is the same when you do the policy enforcement, even for the DSCP. Yes. So you use those you use this information to enforce the policy, and then you know what is indicates. But again, here it doesn't needs to know all the information related with the privacy.
Okay, I think I understand. There was something misleading on one of the slides. Thank you.
Okay, thank you. Yeah, we will clarify. Yeah.
Greg, if you want to go with your question. We have about 2 minutes before next presentation.
So I just want to appreciate if you can clarify the APN parameters. Do they explicitly in any way convey the bandwidth requirements, some other performance requirements, like scheduling policy?
Okay. Yeah. Okay. Oh, go ahead, please, Shuping.
No, please.
Yes. Currently, we think that the bandwidth can be carried in the parameters, and as I mentioned in my presentation, I think this definition, this attribute is open. It can carry other informations based on the actual requirement of the use cases.
But
do you want to see that?
Okay, so if the APN parameters convey bandwidth requirement, then what you think happens if the transit node cannot comply with this requirement? If the packet gets dropped?
Yeah, Greg, let me clarify. So first, the parameters, how to use the parameters is a topic we can investigate in the future. And also currently we only identify the network performance parameters that we could use. And how to use it in the transit node. Again, I just answered before, I don't think that will be used by the transit node.
But if the transit node doesn't use it, what's the purpose of it? If you use it only on ingress, why do you need to carry it through the network if the transit nodes are not using? I thought that it might have the benefit on a transit node because you want to maintain the shape of your flow and use this information in a transit node. So because you do the policing and shaping in the transit nodes, and that been demonstrated that improves the overall service quality.
Shipping.
But if you don't do that, then what's the purpose including it? I'm kind of puzzled.
I need to interrupt.
But
Shipping,
that's
before
okay, thank
you answer that, and then that was a great question, Greg. It's just Shipping, we need to move on with your presentation, and Greg will get back to your point. Yeah, I'm interested too. That's why. So go ahead, Shipping.
Yes, just a quick clarify. The transit node is not doesn't have to be the policy enforcement node. Yeah. Okay. So I will start my presentation. Here is about the work items to be covered in this potential APN working group. Next, please. So here gives like overview of the works that can be covered. I have presented before. Here I use two colors. One indicates, green indicates the new work, and yellow indicates the work that we need to do based on the existing work. So it covers from the data plane to the control plane and the architectures and the new services that can be supported by APN. So first, in the data plane, the core work we need to work on is that APN attribute. And so based on the previous presentations, we would know what we need to include in this APN attribute and what will be the reasonable design. And then, so how to carry the APN attribute over the various encapsulations, the tunnel encapsulations. It doesn't have to be MPLS, and it could be IPv6, SRv6, and even overlay protocols. And in the control plane, we would need protocols extensions to exchange or to carry the APN attribute and to do the policy enforcement. And for the management, and we would need the Young model to define the Young model. And for example, to enforce the mapping relationship between the rules and the APN attribute. And on the top, the architecture, which was also very important, and the fundamental work, the framework. And we can see that caused a lot of confusions before, and we need to have a very clear framework to be defined. And here we would need the help from maybe cross areas. And here again, the problem statement. We have, after this so long work discussions, we have a very clear problem to be solved. So we have a clear problem statement, and that is also need to do within the group, and also the use cases, and some very key use cases that could show what APN could do, and also the security privacy issues, and we have been challenged upon, and we would need to address that and give a clear statement on that. And on top is the new services. With APN, we could further support the fine granular network slicing, .NET SFC, and network performance management, and also SLA guarantee. Next, please. Yes, so what would this working group deliver? And first, the statement. And it's very important. This working group will not publish anything that violates the user's privacy and security. And that will be stated, included in the charter. And so we have 6 work items. And first, the framework and the problem statement. That is fundamental. We need to clearly define that. And second is the use cases. We have already a few of them, and we need to refine further in details and in more clear manner. And third is the APN attribute, what we need to include, and how we need to design and in which structure, and what fields in the existing packet headers will need to map to this APN attribute. Next, please. And then is first is the data plane encapsulations. So we would need some priorities. And but the core protocols would be the MPLS, IPv6, and some protocols in MV03, that is some overlay protocols. And there might be some other possible protocols, and people might want to also investigate, such as GTPU or multicast. And then is about the management and control plane extensions. So first is about the management plane young model netconf. And we need that to enforce the mapping relationship between the rules of the packet header and into the APN attribute, and also the attribute into the policies. And in the control plane protocol extensions, we would need the BGP or PSAP and those southbound interface to enforce the APN and the policies. Those policies are rules I just mentioned. And here IGP, because the APN attribute is not actually for routing, and whether we will need IGP, but there are already some similar work in LSR we could refer to. And next, please. Yeah, thank you.
Robin, you wanted to answer some question or ask a question? Go ahead. Robin, once, twice, there you go.
Hello?
Yeah, we can hear you.
Okay. I just use to clarify for the Greg the issue that one because that's Greg mentioned that's the how to process the parameter. So I think that's about the solution. So I think that's is now it's open. Yeah. So I that's my comments. Yeah.
Okay, Greg, if you want to go, please.
So you identify as one of a group of encapsulations for APN to work on as overlay protocols, Geneve, VXLAN, GUI probably. Why you see the need? If you do that at IPv6 layer, So, and why do you need to do it overlay? Why their tunnel, IPv6 tunnel, is not sufficient?
Yeah, it just here is all based on the deployment scenarios. And in some cases, the overlay protocols, the VXLAN and GNIF may not be IPv6 based. So, but they could still be used to support APN. That is the thought.
Okay, if they're not IPv6 based, then what's their based? Are you suggesting that they're putting packets on a wire just in Geneva encapsulation without any other encapsulation?
Yes, we are considering using the existing encapsulation and maybe some with some extensions and to carry those APN attribute.
Can you name some of existing encapsulations that you have in mind?
So here, for example, if we have the IPv6, we could consider using the extension headers. If we use the VXLAN GPE and currently they are using the shame header, we could also refer to that.
Okay.
Hey, Greg, sorry to interrupt again. We need to wrap up on Shuping's presentation so we can go back on.
Okay, that's okay. I'll probably wait for the Q&A session.
Good.
Thank you.
Adrian, you want to run us through the questions and we'll move on to the open mic?
Yeah, sure. So in fact, we're a little bit ahead on the agenda, which is good because I think we've got lots and lots of open questions. Some of them are about how does the technology work, and some of them are about what's it for. And quite a lot of them, I think, are about why can't we do this with what we've already got. A reminder, you don't have to address these questions, but it may help you to think about them. And then I think we should just simply run the queue until 5 minutes before the hour or until everybody has talked out, and then we'll wrap up. So go for the queue, and Dan can run it, I guess.
Yeah. So Zawi, I'd like you to go first so I don't have to pull you out.
Okay. So I have two top-level comments. The first one is that the entire problem domain and solution was considered so far for APN, I think is already well covered by the IETF network slicing. I actually have one slide with quotes from the IETF network slicing framework document. I would like to share it, but we don't have to do it now. My second comment is that the APN ID and APN attribute, even though they are claiming they are opaque, but I don't think the answers earlier confirms that they are opaque, in that when you have to look at individual fields to determine how to forward, then that means it's no longer opaque. And if it's truly opaque, then you do not need to define the individual details. That the routers just look at the opaque number. So I can give the mic to the next person in the queue now, but if I could, in the meantime, if I could share that one slide to better illustrate my first point, that would be great.
Okay, good.
Can you see my screen now?
No, I think probably you have to unshare first, I guess.
Oh, I sent the sharing request. You have to approve it, I think.
Yeah, you should be able to share.
Okay. Is it sharing now?
It's starting.
I'm not seeing the request.
Oh, there we go.
Yeah.
Okay. So as I mentioned, I have 7 sub-bullets there. Basically, the quotes from the IETF network slicing framework document to show that it well covers the APN problem domain and solutions. So as I said, we don't have to go through this one by one now, but okay, sure. Okay.
Yeah, I'm not sure that Miteko is achieving the desired sharing here.
No.
So I don't know, Jeffrey. I mean, yeah, maybe just don't make a 60-minute talk of it, but just really quick.
Okay. Okay, I'll just read them. So an IETF network slice provides the required connectivity between different entities, blah, blah, with a specific performance commitment. That's our first bullet point. The second one is that it is intended that IETF network slices can be created to meet specific requirements, typically expressed as bandwidth, latency variation, and other desired or required characteristics. The next one is IETF network slice combines the connectivity resource requirements and associated network behaviors, such as bandwidth, latency, jitter, and network functions with other resource behaviors. Term slice refers to a set of characteristics and behaviors that separate one type of user traffic from another. IETF network slice assumes that an underlying network is capable of fulfilling all or some of the SLOs to all the traffic in the slice or to specific flows in a slice. And many approaches are currently being worked on to support IETF network slice in IP and MPLS networks with or without the use of segment routing. Most of these approaches utilize a way of marking packets so that network nodes can apply specific routing and forwarding behaviors to packets that belong to different IETF network slices. The realization can be achieved in a form of either physical logic connectivity using VPNs, virtual networks, or a variety of tunneling technologies such as segment routing, MPLS, and etc. And also, a slice aggregate concept brought up in the some draft best bar drafts is it's an extension to the network slicing. A slice aggregate is basically a collection of packets. It's very similar to the behavior aggregate concept in the DiffServ days, but here obviously it can be at any granularity level, and it can be identified by an opaque number, for example, an MPLS label that Derek mentioned earlier.
Hey, Jeff.
So those are some codes. Yes, I'm done actually.
Okay. Yeah, because we need to wrap up. Look at the queue. There's a lot of people that wants to have some comment and question. Can you wrap up?
Yeah, I'm done. I'm done basically.
Okay,
basically, I think that network slicing already covers this. Thank you.
Thanks. Daniel, go ahead, please, with your question. Oh, there's a...
Can you hear me?
Yeah, there's two.
You skip over.
I just realized there's two.
Yeah.
Daniel,
there's two Daniel.
Dan B, go ahead, you stayed there. So go ahead with your question.
Yeah, so I have a few questions and some comments. So the question was around the work that you expect an APN working group to do. Is it more aligned around creating lots of informational drafts or RFCs around how to implement APN with the various encapsulation protocols? Or are there actually legitimate creation of work that needs that? Because I haven't seen it aside from maybe the APN ID. What I've transpired is more around how to leverage the protocol. Maybe I'm wrong in the interpretation. So maybe someone can answer that question, and I'll come back on the queue for comments on overall APN.
Shuping or Robin, you want to take that question?
because that is to my presentation. Yeah, so besides, we will have some information drafts and probably for the use cases. But for, you could see we do need some standards to be defined, like the APN attribute, how to define the structures and the design. And also it's like the header of APN. And also in the data plane and the control plane and the management plane. And we all need some standards to be defined in those areas.
Yeah, thanks. Tarek, go ahead with your question and comment.
Wasn't sure I was at the top of the queue or not, but
yeah.
My question is very much similar to what Daniel B had asked. Is Xupeng in her presentation had presented multiple extensions in data plane and control plane routing protocols, but I haven't seen the gap analysis being done. Existing tools can achieve what she's asking for. Did we look at the tools that we have, and is it short of delivering what we expect? Thank you.
Thanks. Peng, you're next.
Peng Liu from China Mobile, and I have the following comments. So first, for the third question, since we have the use case that APN is used for edge computing, so APN can work in the network domain controlled by one operator, and it will be not harmful to others. And for the fourth question, why granularity network service provided by APN is good for the application and the users. And the operator can also provide differentiated network service based on APN and may benefit from it. And for the last question, I would like to work on the topic. In the view of previous discussion on structure, scenarios, and encapsulation, I think this work is different from the traditional routing work. So to set up a WG to have all possible work together may be better. Okay, that's all. Thanks.
Thanks. Ted, if you want to go.
Ted Hardy speaking. Thanks very much to the presenters, in particular to Xupeng, for her presentation of the commitments of the working group toward privacy and security in the course of the intended work. And I also appreciate the fact that there is already a draft produced for the intended working group, which deals with that. Unfortunately, I think there's a problem. And I think that problem is around the richness of the intended identifier, and the placement of the ingress point means that depending on how it's structured, it could end up being an identifier which carries a great deal more information than the 5-tuple itself would. And the result of that is that it needs to be handled very, very carefully. The current proposal in the documents, as I understand it, is that this would be bleached at the edge of a network's set of domains. So if an operator was multi-domain, it would be bleached before it left the operator's domain so that it did not cross outside of the operator's policy control. The difficulty there is you don't really have a mechanism for doing that inside the protocol, because you're moving from domain to domain when they are controlled by a single operator. The encap and decap points are flexible. And the result of that is you could have the decap point outside of the operator and subvert, essentially by collusion, the entirety of the proposed solution for this problem. I think if you tackle that and say, okay, we will handle that and make sure that there is some way to ensure that the decap point is known, say to the endpoint or in some other way, one, you're going to increase the complexity of producing the solution here enormously. And two, you're going to end up losing, the multi-domain single operator use case, or more likely both. I think that reads on C and D. Realistically, in order to avoid APN becoming the handy place for identifying metadata across all encapsulation formats, you're going to have to do a great deal of work. And that means that worth the cost of development and deployment, in reality, I don't believe it will be. So I think we have to be very honest with ourselves here that there are other parts of the packet already that have the same risks. It's been pointed out in the chat, for example, that flow labels can carry much of the same information. But I think adding another one, and in particular adding one that's meant to be generic across all of them, is not the right thing for us to do at this time. Thank you very much.
Thanks, Ted. Daniel Wine, if you want to go.
Daniel Wang speaking from ZTE. Thanks for the wonderful presentation of all presenters. I have two questions. The first one is I would appreciate if anyone could clarify that. Is there an top level attribute structure defined over all of the Tallow protocols, or the attribute structure will be specified Tallow by Tallow? This is my first question. The second one is actually what I'm confused about is when it comes to the policy employment on the network closed, it's only involved with the combination of flow identification and the according attributes. And so why do we have to do this on the basis of packet by packet by encapsulating the attributes in the data plane? Thank you.
Thanks. Watson. Yeah, go ahead.
I've covered. I think there's a big problem with this piece of work, which is it's not clear why you ever have the problem of having multiple domains within one administrative domain with incompatible tunneling protocols. You're going to need to change all your hardware to do this. You're going to need to change your software to put on this new tunneling layer and then hook up the tunneling layers you've already got. If you're going to do all that work, can't you just pick a tunneling layer like MPLS or the DetNet enhancements or something that lets you get the quality of service and policy enforcement things you want? And there's a huge tension here between having a complex, rich structured identifier and very efficiently pushing packets around. And it's not clear where this work falls on that. It seems like there's a problem I complained about before, which is there isn't a clearly defined use case that we can map onto a set of things and see, okay, this is exactly where the gap is. It seems to be a very protean. So we need an identifier, we need a very arbitrary identifier, and it needs to control these core networking functions. I don't think that's really feasible. And I think when it comes to quality of service, there's been a lot of work already. And the fact that the draft authors haven't been involved in DetNet, it just doesn't seem to make a lot of sense to pursue independently something very similar, especially when it cuts across all these things.
Thanks, Jana. Jana, if you want to go with your question and comment.
Hi, thank you for the presentation. And I'm going to start off by saying that I'm going to repeat some of Ted's points. Probably mostly what I'm saying has been covered by Ted. So it's both a good and a bad idea to go after him for me right now. I want to repeat it, however, because I think it's worth repeating. Watson pointed this out as well, that the richness of information here, to me, that is a big part of the problem I have with the proposal at the moment. Richness is not always a good thing, and in particular when it comes to the ability to describe data and for the ability to arbitrarily share that rich metadata about whatever you're observing. Without putting any serious bounds on this, without actually doing a serious, without having a good understanding of what exactly that could entail, basically we can imagine any use of this information and this metadata. And I want to draw attention to that. We've seen proposals like this in the past where, again, a generic structure is used to describe a specific problem or as a solution to a specific problem. And I always find that that it's lost on the proponents that the simple notion of the fact that this is a general structure is in fact the problem. If the solution was much more specific, it would force you to think about the problems much more precisely. And as a result, the solution might be much more meaningful for the problem that you're trying to solve. If all you're trying to do is build a mechanism that will allow you to solve all future problems, that also has the potential and will definitely create a lot more problems in the future for us to solve again. So, yeah, I mean, those are pretty big issues for me at this point. And again, as Ted said, these are significant in the sense that APN, this particular piece of work, can actually be significantly harmful in the way that it is currently described.
Thank you, Jenna. Fang, if you want to go.
Yang from China Mobile. We have same opinion with Peng Liu on this APN. But before talking about the opinion on this APN, I have a question on this. The question is, if we have many kind of tunnels, in case of we have end-to-end tunnel, just a single tunnel for end-to-end connection, that's clear that APN can work correctly and as expected. But in case of we have many domains and each domain has different kind of tunnel encapsulation, then how to handle the APN handover? That is one question. And after this question, I want to talk about my opinion on this APN. APN is helpful for more fine granularity of the applications to carry in the packet. So I support to have the APN for the future work. And the first question is, the question listed here is, do you think APN will be harmful in any way? I think that if APN is managed in one single operator, that is a limited domain, that is manageable. So that's one question. And then I'm for the deliverables, I'm thinking that only the framework and the mechanism is not sufficient for supporting the future work. And I'm thinking that at least we need to define some concrete common applications, like code point and similar with the DSCP and the flow labels, that can be a guide for the device vendors to do their implementation. That is my suggestion to the question deliverables. And the third, I think we can have the work group to start the solution work as soon as possible.
Thank you, Fang, for your
question.
Good. Daniel, Dan B, if you want to go. I think you want to come back.
Can you hear me now? Yeah. So this one is not about a question, it's about a comment. So I do agree that there is a need to work on the application piece of networking. I'm not sure that it needs something new. I think the notion that an application needs to be able to talk to another right now, if you look at how those systems are built, they do actually create a lot of new ways of doing things using service meshes, AMQP protocol in banking, and some military systems which rely on the existing network. I think there's a gap. I've discussed this a while ago in PanRG as well when it started, is that we have the way of the network to express its systems. We talk about how an application should express its logic, but the developer itself doesn't want to deal with that model, so there needs to be an abstraction layer from a developer to build an application that should not have to worry about which encapsulation is, and I don't think that abstraction needs to be another protocol. I think it should be some kind of orchestration systems or means in the application level itself to be able to make those requests, and the network should be able to rely and deploy it based on the available mechanisms. That personally that's my current opinion. So
thanks, Dan. Greg.
I'm just going to jump in before Greg and point out we have 15 minutes of discussion left. There's quite a long queue, so please all try to keep your points really brief and to the point.
So with that in mind, Greg, go ahead.
Yes. As Lou had pointed out, DetNet already solved its problem, and it doesn't appear that there is need for another mechanism to solve the DetNet problem. I concur with Ted with his concerns, and actually I agree with Daniel very much that the problem that does exist doesn't have to be solved in a data plane. We do have some other mechanisms, and management plane is one of them, where their policies and application requirements can be conveyed. So that probably would be more reasonable. And I would repeat the other suggestion is just look at existing mechanisms and probably start with the RFC 6437 that defined flow label for IPv6, because this RFC does not say that flow label must be used and only used for load balancing in ECMP and lag. Okay, thank you.
Yeah, so guys, to accelerate many more comments, I'd like to give the mic to some other people that haven't speak yet. So Ron Bonica, if you want to go, please.
I think what we have here, the use cases are a bit light. When I say they're light, what I mean by that is the use cases that have been presented right now don't justify the broad charter that the proponents are asking for. Because they're a bit light, it also makes it difficult to do a gap analysis. Do we already have what we need? It also makes it difficult to know whether it's worth altering the forwarding plane, which we know is going to be a big problem. And then the third problem with chartering this working group is that it would span so many areas. It would span forwarding plane, it would span MPLS, it would span IPv6. So probably a good idea would be to work on the use cases, know what problem we're trying to solve a little bit more clearly first. Then we can do a more succinct gap analysis.
Thanks, Ron. Shui, if you want to go. Yeah.
For consistency, we have the use case of implementing APN to realize game acceleration. Based on the implementation of APN, the APN attribute is only used in our network domain and will not be harmful to other network. I think the implementation process is according to the contract with the game service provider. We can also explore better business models to achieve win-win cooperation through APN. So I think this work makes a lot of sense. I will contribute to the work, and maybe there are more application attributed needed to be defined. So a new working group is a better way to do this work. That's all.
Thank you. Jerry? Sorry if I don't pronounce your name correctly. Jerry.
Yes, thank you. So I don't have a complaint. I actually have a suggestion, hopefully a constructive one. And the suggestion is that, maybe what you should be doing is write a document that assumes this model where one does one lookup and then encodes some information in a very small constrained set of bits. And then this document would explain how to do that with some of the existing IETF technologies, such as MPLS or SFC and whatnot. So I think that would be a useful document for us to read. So please work with that. Thank you.
Thanks. Jing Wang, sorry if I don't pronounce your name right. Go ahead, please.
Hello?
Yeah, we can hear you.
Okay. I'm Jiro from Huawei. I don't have question about this buff, but I have some comments. As I explained in the interim meeting, Matcast is also a useful service that needs to be considered. I think APN can combine with Matcast, and it should be taken into account how the APN attribute is carried along with the kind of Matcast tunnel. So I will be very interested in this work and support to have a new working group. I will contribute to this. Thank you.
Thank you. Richard, if you want to go.
Okay, this is Richard. I'm from Yale. So one thing I want to emphasize is I'm academia, so therefore I'm not really from industry. But what I do want to say is I like this work. And the particular reason I want to say it is I forgot who gave the presentation to show there are all kinds of labels. We have flow labels, we have DSDP, and so on. And all kinds of things defined already in the packet headers. If we learn one thing in academia, for example, in programming language theory, is you probably want to have some kind of type theory. Because whenever you have static type, and if you have semantics defined, it's great. You can catch all the bugs, and you don't want to do all kind of hacking and so on. This is great. So overall, right now, there are a lot of different flow labels, MPS labels, and the code point are all defined, but they all have very well narrowly defined types or essential type system. Here, APN might be a very good way to essentially introduce some kind of generic type system into the packet header, which is great. And I do have one very quick suggestion. I'll shut up. I do actually see a lot of use cases, and somehow, and also I do have a lot of like questions about, for example, the encoding of the identifier format and so on. For example, I can see the APN as a way of signaling from applications to the network. And actually, I also see a lot of argument talking about essentially you can really compress the 5-tuple lookup to essentially some kind of APN ID lookup. But that's actually a totally different use cases. For example, for the compressing or essentially the reducing expensive lookup, of course, there are early work in academia, for example, from Ion Stalka talking about core seedless networking. Basically, the philosophy is you want to do a lot of things at the edge, and you want to do a lot of things in the core, make a core to be lightweight. And there are all kinds of things which you probably want to be a little more careful to define all the semantics of the identifiers as carefully as possible. But then actually be very, very valuable. And finally, we can have such a system in the network.
Thank you. I would like to suggest the last four of the queue, Eric, Dirk, Jim, and Drew, would try to go with your comment and question inside 8 minutes if you can. So Eric, go ahead.
Yes, thank you. I just wanted to ask about the limits of what can be used, what can be gleaned and put into an identifier based on the 5-tuple in a world of like increasingly encrypted everything. How much meaningful identifier space is there actually, and particularly also in a world where we start having lots of mask tunneling and OHTTP proxies. How useful is this kind of classification?
All right, thanks. Dirk?
Okay, yeah, maybe this was a comment already given by several people, but perhaps I can't repeat. I think the APN work has done a good job in pointing us to the need for better traffic classification in the internet, which is typically really an interdomain scenario, and I want to thank them for that. But what I learned here is that they introduced just a new APN domain in addition to the existing SFC and MPLS and SR-Physics domains and so, and claiming that they can grant infinite granularity, if this is even possible. That seems to me this is just another approach, and the expected costs are also perhaps infinite. So I'm not sure. So, but I think we should work on the questions further on, but perhaps in the existing working group approaches. Thanks.
Thank you. Jim?
Thanks, Daniel. I just wanted to make a comment from my understanding of what APN's actually trying to do and how it does differ from network slicing. I've always thought of network slicing as really looking at how do I dedicate resources in the network to specific flows. What APN, at least from my perspective, is ultimately trying to do is identify who you are, what you are, where you are, and what you're trying to do, and map that to an identifier that can be used to enforce policy. And that policy might be this traffic needs to go through a particular network slice, or this traffic needs to go through a particular service chain, or this traffic needs to go through a particular segment routing path. And the who you are is, is this Jim? Is it his wife? Is it one of his kids? Is it the neighbors using his Wi-Fi? Is it some guest in his house? Is he on an iPad? Is he on an iPod? Is he on his Xbox? Is he in his home office, or is he in a controlled environment such as a company office, or is he down the library or in the pub? And what am I actually trying to do? And I map that to an identifier that then I can enforce policy in the network. So I think that's how it differs. But, perhaps it's difficult in these cases because you have to choose simplified use cases to try and get the points across. And, perhaps more detailed use cases are required. But I just wanted to make that comment and get that out there. Thanks.
Thank you. Drew? Yeah, go ahead.
Hey, just a very quick comment on the gap analysis. I think one thing that we can do with the gap analysis is also try to focus on why do we need an agnostic mechanism for this work, and why, adding things into IOM or NSH would be a bit of a hack, and why we need to start from a clean state and design this in an agnostic mechanism. And it also adds on to the point that by this work, if it is distributed across multiple working groups, would be a bit of a pain, and having a common place would be really helpful because of the issues that are kind of highlighted today. We need something where those things can be handled in a common place in an agnostic fashion and then applied to various data planes. Thank you.
Thank you. Shuping or Robin, you've been in the queue for quite some time. I'm pretty sure you have some answer. Are you, yeah, go ahead, please.
Yes, so here I can see Charles. Maybe we can let him go first.
Charles, go ahead.
Yeah, just a quick note on the privacy, right? I'd just like to make my standard reminder that there is more and more communications that doesn't include a user with privacy concerns, but more and more machine-to-machine communication. And, there is a lot of auditing and other transparency and regulation requirements where, the information carried in this headers or so will have completely perfect semantic without introducing any privacy concerns.
Thank you. Shuping or Robin, it's the time before we close. Go ahead.
I can just basically some clarifications and to the questions before, and also the chat box. So I think what we haven't addressed in this meeting is that we are not creating any new APN domain. We are based on the existing network deployment, and we are also building on the existing business model. The use cases we gave here, you could say it's light, but we have been presenting use cases since very beginning, and since 108, we have for a few operators have already presented their use cases. We have presented particular use cases and a more general one and in much more details. So whichever we have presented so much. So in this meeting within this short 10 minutes, we will give a very clear use case. It will be simple, clear, and straightforward for people could catch the key point. So here, we already see that is the existing business model for the cloud lease line. That is when you buy this cloud lease line, and that is for the 2B business. And here we focus more on the 2B business. And the enterprise buy this cloud lease line, that generally is very expensive, and they must tell the operators what will be their services and what will be their requirements. And they will tell the operators what will be the key user groups of some department, for example, finance or marketing. And so in that case, the operators will know some information of those key user groups or key application group. So they could perform some fine granular treatment on this key traffic. You know, currently the cloud lease line is they have to they can only keep like 50% bandwidth. And then yeah.
Can you wrap up in 5 seconds, because we need to move on and keep the last 5 minutes.
Yes, and about the privacy security, and yes, nothing is perfect. We just at the start, although we have been working about 2 years on that, but we need help on these privacy and security issues, and we have to do the effort, and we also need the help from the community to help us to solve this.
Thank you. Adrian, back to you.
Thank you.
Wow, right. Thank you. That was a mammoth queue at one point, and sorry to those who have just been cut off. The chairs have been typing at each other frantically during the meeting, and I've scribbled some notes. What I think we heard was that there's potentially overlap here between what APN wants to do and what other things can do or want to do. Some of that was covered in Guillen's slides, but DetNet and slicing were not, and that needs more attention. Potentially that APN is a solution for slicing, or that DetNet is a solution for APN, and so on. So that needs attention. Quite a lot of concern about privacy, and although that was explicitly excluded, there's I think it was Ted pointed out, there's risks of accidental breaches and subversion of decapsulation, as well as the worry about being an arbitrary thing for carrying metadata. There was discussion about whether this should be applied to multiple transport or underlay protocols, or whether it's more sensible to pick one and say this is what you use for APN. And part of that led to, or comes from, it being very unclear whether the use cases are general or more open. And so there needs to be more focus probably on a killer or some killer use cases, and in particular, what's needed in the attributes and the policies to expose those use cases. And one other thing I had was, I think from that and from the metadata, it's not clear what can be, what the difference between what needs to be in an APN attribute and what could be in an APN attribute. And then my last scribble here says, beware of ubiquitous encryption and making sure that APN is useful in that context. So that's everything I heard, and I think it's Martin gets the remaining 2 minutes.
Good.
Hopefully my network won't break within those 2 minutes. Thank you all. Thank you very much. I think it was a success. Success in its forcing function to bring an important number of people together to discuss a specific topic. However, I would say that there is undeniably a gap that needs to be filled between the proponents and the community. Maybe I'm a bit optimistic in the sense that it seems to me that the objective is generally well understood. However, it is clear to me that the community is still confused on why we can't achieve this objective. Maybe not uniformly, but using existing tech. And my network. No, it's okay. You still hear me?
Yeah.
Yep, you're still good.
Okay. Echoing the words I've said at the beginning, I think the proponents need to find the ways to convince more people and bring more diversity bring more diversity to their proposal. And so what are the next steps? Maybe I'll pick up the idea of YARI, which I understood as try to write a draft, taking one example for a specific use case you have, which is clearly well defined. That's not a problem for me from my perspective, but maybe try to target a specific data plane technology and target a working group and see how it goes. Because we are engineers and we do need to understand how things work. And that would be the advice I give to the proponents.
Okay, thank you, Martin. And I presume you'll sit and think about this for a bit and then drop an email to the APN list. Yep.
Of course, yeah. I will summarize that on the list.
So I think our time is up. Can I thank the minute takers who've had a tremendous task to deal with, and ask everybody who spoke at the mic to take a couple of minutes just to go to CodeMD and check that what they wrote down was approximately what you said. And I think we're done. Thanks to Bob and Dan for actually pedaling underneath while I got to talk and look great.
Thank you thank you everyone.
Yes, thank you, Adrian and Dan and Martin.
Thanks guys.
And everyone who attended. Yeah, we had almost 200 people.
I've never had to stop a CodeMD, a MeetEcho meeting. I don't know what we do. Do we just kind of go away? And
I think we just say leave the room.
We were not trying to stop.
It wasn't an easy working group or BOF to manage. So thank you guys.
You're welcome.
I think you need to leave the room as chairs, and that closes the session.
Well, and at least it stops it being a problem for us.
Right.
Thank you, guys. Thank you, everyone.
Okay.